Okay, so I have posted homework 3 and homework 4. Homework 3 is available under week 4, and homework 4 is available under week 6. Now, for homework 3, we'll cover things like dplyr and rvest and regular expressions, and we're going to cover dplyr today, and we'll cover rvest on Friday and regular expressions on Monday. So, so you can get started on homework 3. Meanwhile, homework 4 covers, we've already learned everything you need to do to finish homework 4, okay? But I wanted to give you guys enough time to work on it, so it's not due until week 7. With that said, please start, or at least take a look and get started on homework 4 now. Okay, you'll be using reference class objects, which use kind of the message passing and are mutable. And you'll use that to keep track of player status and and the game board and things like that. And of course, you're going to have to expand on your reference class objects and things like that. I've tried to make it very clear what is expected, and I've even posted what your solutions should look like. So I coded it up myself, and you'll be graded on kind of what happens during these 20 turns, because they should match up, because this part is deterministic. I've got two kinds of dice programmed, and then we also have some random dice that are programmed, and when you use the random dice, it should list off which spaces end up being most frequent. So Illinois Avenue, Go, Tennessee Avenue, these are the ones that should be most frequently landed upon. And you can see, look up stuff online regarding space frequencies, and they likely line up with these results as well. But anyway, I think it's an interesting problem, and it kind of alludes to the idea of using the computer to answer questions. But anyway, we'll take a look at dplyr and tidyr. And so this guy Garrett, he works for our studio. He hosted a webinar a few years back when dplyr was still very new, and he produced some slides, and they're really good. So I'm just using them. I'm just linking to them. This will take you to GitHub, and GitHub does a preview, but there's like 150 slides, so I think they only preview like the first 50 or so. So go ahead and just click download, and then you can open it up and follow along on your machine. And anyway, so we'll go ahead and work through his slides here. I am not Garrett, but you will need these two packages, or these are the two packages that we're going to take a look at today: tidyr and dplyr. Okay, and these are under the umbrella known as the tidyverse of packages. Okay, so the tidyverse is basically a set of packages that are basically programmed by Hadley Wickham and the RStudio team. Okay, and they produce these high quality packages that have really made working with the data in R a lot easier. Okay, and so in Stats 20 you learn things like subset and using logical filtering, even earlier in this class we used logical filtering. We used a logical vector to kind of filter out the rows that we want. dplyr makes that basically a lot easier and a lot faster, and I highly recommend its usage. And so it's worth spending time to cover this. There's some cheat sheets. They've actually updated this. This is the one that's a few years old. The newer one covers the same kind of stuff but is newer, okay? And one thing you'll notice is that when we print out data frames in after loading dplyr and tidyr, they're going to come out as tibbles, okay? So tibble is basically a data frame, but it's got some extra properties. And in fact, if you look up class of a tibble, it's going to be, you're going to get a vector, and it's going to say tibble, data frame, and whatever else shows up, okay? And basically, the tibbles are aware of how big your console window is, and will print only what will fit in the window. And so we'll work through all of this, okay? And then I think you guys are familiar with capital V view. This is what happens if you load a data set. Oops, this is part of my solutions here for a monopoly. If we load a data set into R, okay, and we get something like if you load the iris data set, okay, it loads up here, and then you can click capital V view, or type in capital V view iris, and it pulls it up. Let me close that out, and it will make it look kind of like an Excel spreadsheet over here. Or if you just come along and you click the thing over here, this clicking the data set or data frame over here causes it to appear in view mode, okay? Which just allows you to kind of scroll through it, and that's just a nice feature of RStudio, which is I think you guys are familiar with that. Okay, we'll encounter the pipe operator, and I'm not sure if you guys are familiar with this, but we'll encounter it. Okay, and so anyway, data wrangling, they say 50 to 80% of your time. I don't know. I guess it depends. But I will say this, okay? DataFest is coming up, and that's the first week of spring quarter, and you can just spend a good chunk of time thinking and doing your work in dplyr, and that would, and I think if you have a compelling, I don't know, story or just an idea and thought that you explore, you can win DataFest using just dplyr, okay? I've seen past winners where they had a thoughtful question and a thoughtful investigation, and I would say 99% of their work was done in dplyr, and then, just the last bit, they created a plot to kind of summarize it. But really, the actual summary came in the stuff that was done in dplyr, and it was just properly thinking through some questions, figuring out what groups to compare, creating summary statistics for those groups, and finding the proper comparison. Okay, I'm not saying just throw stuff at dplyr, but the group had thought about it. And had a thoughtful inquiry, and their tool that they used to investigate was just dplyr. And other than making the last plot at the end, it was their entire analysis was done in dplyr, and they won like the Judge's Choice Award or something. So so you can win. You can do a lot of stuff. Okay. Anyway, the two packages we're looking at, tidyr and dplyr. These are the goals, okay? We want to kind of reshape some data sometimes, or we want to reveal some information, okay? And are you guys familiar with the term tidy data? Okay. Well, the idea behind tidy data is that you will have a rectangle of data where each row is an observation and each column is a variable, okay? These are like little play data sets, okay, that you can use by using loading library exploratory data analysis with R. This is not a regular package that's released on CRAN. So CRAN is the network of R servers. So when you like download R, there's like a network around the world of these servers. One of the servers is here on UCLA's campus, and they basically, their function is to distribute packages and things like that, okay? But there's a bit of, you know, there's a bar of entry that you need before you can release a package that will get distributed throughout the CRAN network. And so if you want to make your own little package, okay, but not make it an official thing, you can put it up to GitHub and things like that. And so anyway, you might need to load DevTools and then install a package from GitHub using these two commands here, okay, if you want to follow along and use these data sets in R. And so actually, I did this on my home computer. Let me see if I have. Okay, so I don't actually have it yet, so I got to do this. All right, so I'll do install that packages. DevTools. So DevTools is something that's on CRAN, and this will download, and then all right, there we go. And then I want DevTools install GitHub RStudio EDA AWR. Okay, so we'll go ahead and do that as well. We'll let it finish. All right, so DevTools install underscore GitHub RStudio EDA AWR. Okay, I'll let that do it. Okay, so anyway, these are some of the tables. These are the tiny little tables that are available. Okay, storms is in tidy form. Okay, each column is a variable. We got storm name, wind speed, and air pressure. Storm, wind speed, air pressure, and the date. Each column is a variable, okay? And each row is an observation. Whereas if you look at this cases, this is tuberculosis cases in 3 countries. What are the variables that we're seeing here, okay? We could say one of the variables is the country, France, Germany, and the United States, and then the other variable is the year, okay? But we don't have the year in a single column. We spread the years out across the columns. We got one column for 2011, a column for 2012, and a column for 2013, okay? And so so the years are there, and then the values, the count, how many cases of tuberculosis appeared, show up like this, okay? Here's another table. We've got city, particle size, and amount, okay? And this is fine, but somebody might say, you know what, the variables, if we look at this, we've got New York twice, okay? The variables should just be city, how many large particles we have, and how many small particles we have, okay? So we've got city, and then we've got the amount of large particles, which appear in every other row, and we've got the amount of small particles in every other row, all right? And so if you wanted the data like that, it's quite tricky to get it, okay? If it's in tidy form, you can access the data frames using just $ notation. You can say, I want the storms $wind, and you'll get the wind speed, okay? If you want something like this, it's not so easy, okay? You've got to kind of do odd indices and even indices and things like that. It's no good, okay? Again, to kind of just emphasize why tidy data, having each observation be a row and each column be a variable, why that's useful is that you can do these operations, these window operations that are vectorized. So if somehow you want to calculate the ratio between air pressure and wind speed, and you just wanted to do storms $pressure divided by storms $wind, it's going to be vector, and it's going to do 1007 divided by 110, 1009 divided by 45. These numbers are all wrong, but it's going to match them up by row, okay? And it's going to do a vectorized operation, which is really nice, okay? So this is what we mean by tidy data. Each variable is its own column, each observation is its own row, and you know, if you've got different types of data, they're going to be in different tables. Let me finish this. Okay, so we're going to call library EDAWR, and we'll say data storms. All right, and if I call storms, it looks like that. And then we got data cases, tuberculosis cases. Cases looks like this. Do I need to make my text bigger? Probably. Let me. Okay, so we've got cases there, and then I forget what the other one. Oh, pollution, data pollution. Okay, and so these are how the data is stored in R, and storms is in tidy form. Okay, and so again, you can just do storms $wind, or storms $pressure divided by storms $wind. Okay, and it does a vectorized operation, doing each of these things there, okay? So we like tidy data. All right, so tidyr is the package that lets you manipulate things that are not in tidy form into tidy form, okay? So you can call library tidyr, and I guess my population, okay. So anyway, and we can, kind of the two main verbs, or the main functions that we're going to be using are gather and spread. Okay. So just a quick question. If we reformat this table into tidy form so that we have the variables country, year, and n, number of cases, how many columns would we have, and how many rows would we have? Okay, so number of columns, this is easy. How many columns will we have? 3. 3, right? Country, year, and n. Okay? How many rows will we have?
9.
We'll have 9, okay? We're going to need one for every value, one for each country, year combination, okay? So here we've got, this is how it is, and if we turn it into tidy form, we want country, year, and n, and we're going to have one row for France. 2011 had 7,000 cases. Okay, then we're going to have Germany in 2011 had 5,800 cases, and we fill this up, and we're going to have 9 rows because we have 9 observations recorded. Okay, and once you have that, now you've got 3 columns. And the verb here is called gather, okay? And the reason why we call it gather is because we've gathered the data that's across 3 columns into basically 1 column. Okay, so we've gathered, so these values, which are currently found in across 3 different columns, have been gathered into 1. And in order to kind of know what they are, these column headings, the 2011, 2012, and 2013, get gathered into 1 column as well. So the column headings get put into 1 column, and then those values have been gathered into 1 column. Okay? And so the column headings become the new thing, and we have to just give it a key name. We're going to say gather these columns, and it makes sense to call it year, all right? And we're going to say, and then we need to give it a name for the values, okay? And it makes sense to call it n, but you can call it whatever you want, all right? So here, again, I have cases. Here's my cases table, and I'm going to say gather cases, okay? And they say year and n, and those make sense, but again, you can use whatever name you want, okay? So we can call this time frame and count, okay? And then the important thing is which columns get gathered, okay? So we're going to gather columns 2, 3, and 4, so we're going to say 2, 3, and 4, and when you do that, it just, whatever you put here just become the new column names. Okay, is that all right? All right, what if, so here's the cases table, and I'm going to just use year and N, but instead of 2 through 4, what if I did 3 through 4? So I'm gathering columns 3 and 4. Okay, so there's 6 values that are being gathered together into one. So the resulting thing is going to have 6 rows. Okay, what's going to happen to column 2011? So anything that doesn't get gathered just gets repeated. Okay, anything that doesn't get gathered just gets repeated. Okay, so this is what happens. Okay, year 20. Columns 3 and 4, 2012 and 2013 get gathered. So we have 2012, 2012, 2012, 2013, 2013, 2013, and those numbers get gathered into one thing. And this column that says 2011 just gets repeated. Okay, now it feels silly to do something like that, and I agree. But it might make sense. So here we've got cases. Let's say I created a new column in cases. We call this capital, and this is going to be Paris, Berlin, and Washington. Okay, so now here's the cases table. Okay, and so now it kind of makes sense, I think. So if I gather cases and I gather columns 2 through 4, you know, it makes sense to repeat those rows, right? So we had capital, so it makes sense to leave it as, you know, France and Paris, and it doesn't make sense to try to gather the capital in with everyone else. Okay, but there's nothing to stop us either. Okay, so here's cases. Okay, and I could say let's gather, and I might make the mistake and say gather columns 2 through 5. All right, what's going to happen here now? It's gonna gather it. Okay, it's gonna say you want me to gather columns 2, 3, 4, and 5. I'll do it. Okay, and so it gathered those numbers together in a thing, and then it says, oh, you know what? Paris, Berlin, and Washington are also here. Okay, and so now it's like France in the year 2011, but then this is, I don't know, not a year, but it's, you know, France capital. You know, it just takes those columns and throws them together. Okay, so I want to kind of just make sure we have a grip on what gather is doing and how it works and what happens. Like this example makes sense. Okay, but it will still do an operation even if you give it things that don't quite make sense. Okay, things like gathering only columns 3 and 4 will result in 2011 being duplicated. Okay, and then if you have another column and you didn't if you didn't gather it, or if you gather it, it'll show up like this. Okay. All right, is that okay for gather? Okay. Spread is pretty much the inverse operation of gather. Gather says our data is stored across multiple columns and we need to gather them into one column. Spread will say our data is stored in one column, but I actually want to spread them out across multiple columns. Okay, so right now I've got large and small particles, the amount stored in the same column, and I want to create one column for large particles and one column for small particles. So in order to do that, I'm going to use spread. Okay, so if I do this, the resulting data frame will have 3 columns: city, large particles, and small particles. And then how many rows will it have? So currently we've got 3 columns and 6 rows. If we spread out these things across 2 columns, how many rows? We'll have 3 rows. 1 row for New York, 1 row for London, and 1 row for Beijing. Okay? So here's what we have, okay? And when we spread it, okay, New York large 23 will go in the large column, New York small 14 will go in the small column, okay? And we're gonna get 3 rows, 3 columns. Okay, and that's spread, all right? So here, what we do is we say the key is this column, okay? And what spread will do is it will look at for the unique values that appear in this column, and it will create a column for each unique value that appears in the key column. It's gonna, so here it says there's only two unique values, large and small, and so it's gonna create 2 columns. If there was another unique value here, it would create something over there, okay? And then it takes the values and it lines them up accordingly. All right, so here we have pollution. You know, what I'm going to do is I'm going to say spread pollution and look at the size column, and the values that we want to spread out are in the amount column, okay? And it does it and it's done, okay? But here's a few things that you got to watch out for, okay? So what if I'm going to just modify first row, second column, whoops, not spread, pollution, okay? So pollution 1, 2, this is the large here. If for whatever reason we had it written like this, okay? So here's the table now, okay? I've got large, small, but this is all caps large. And then if I apply spread on this, the same exact thing, spread pollution size amount, what do you think is going to happen? How many columns will I end up having? I'm going to have an extra column. I'm going to have a column for large, okay? And then a column for all caps large, okay? Because what it does is it looks through and it finds all the unique values that appear in the size column, or the column that you provide. It's going to look for the unique values, and it's going to make separate columns for each of those unique values. Okay, so here I've got lowercase large 120, 122, and New York does not have a lowercase large value. Okay, whereas when we have all caps large, we have no values for Beijing or London, but we have 23 for New York. Okay, so does that make sense as to why we end up getting this when we spread the columns out? Okay. So let me change this back to regular large, and we'll just make sure that works. Okay, yeah. All right. Similarly, so I've reset it. If the city names, or this thing which currently says New York, if this gets changed to say something like NYC for New York City, and I look at the pollution table now, okay, it looks like this. And if I used spread on this, what do you think will happen? How many columns will I have? I'll still have 3. I'll have lowercase large, lowercase small, and the city name. How many rows will I have? I'll have 4. I'll have a row for Beijing, a row for London, a row for New York, and a row for NYC. Okay, so it says, these are the values that we have for Beijing, values that we have for London. New York, we don't have a large value. We have the small value 14. NYC, we have a large value of 23, and we're missing the value for small. Okay, so so spread will just kind of look up the values in the key and the value columns, and spread them out accordingly. Okay. Okay, and so yeah, spread and gather are basically inverse operations. Spread will take values in one column, spread them out across multiple columns, and on the other hand, if you've got values across multiple columns and you want them into one you gather them together into one, okay? And so you can kind of undo the operations to each other. Okay, there's unite and separate. I think I'm going to just kind of skip this over. This is kind of more like dealing with text things. So if you've got date stored as text, you can split them out as year, month, day, and things like that. Or, you know, I don't know, if you have like serial numbers, like from some kind of company, but the like positions of the serial numbers actually mean something, where it's like, you know, the first 3 characters in the serial represent like which machine it came from or something. You can use separate and unite to do these types of things, okay? But don't, it's not worth going over. The gather and spread, those are the two most important verbs or functions, okay? All right, deployer, this is like my favorite. And these are kind of the verbs that we'll use. And we'll use library deployer. And it says all of these things are being filtered, but that's fine. Okay, and we'll just go ahead and take a look. Okay, select will be select the columns. Filter is filter out rows. Select is for columns, filter is for rows. That's what you've got to remember, okay? Select is for columns, filter is for rows. And then mutate makes new variables. And then the other super powerful thing for deployer is summarize. Okay, I'm just gonna flip through these slides because I think they're straightforward. You can just say select from the table storms. I want to select the column storm and the column pressure, and it's just gonna return back, you know, just a few of the columns, okay? You can give things like minus the column name, okay, and it will return everything but that column. And here's a nice little feature, is you can use kind of the same notation that we use, like 1:3 or 2:4, but you can actually just give it column names. And you can say wind:date, and it will give you back the columns for wind through date, which is quite nice, okay? There's also, you can select columns that's, for example, that end with a certain string or start with a certain string, right? So, for example, let me see. Okay, so in NYC Flights 13, the flights, forget. Okay, data flights, all right, and if we ask for the variables in flight, we've got year, month, day, we've got departure time, scheduled departure time, arrival time, scheduled arrival time, and things like that. So what we can do is we can say select, let me clear out the screen so you guys can see. I can say select from flights, those columns that ends with time, okay? And then it pulls out departure time, scheduled departure time, arrival time, scheduled arrival time, and air time, okay? And you'll notice this is a tibble in that it only prints out kind of the first 10 rows and only the things that kind of fit, okay? So, you can do starts with departure, okay? And we've got departure time and departure delay, things like that, all right? So these are nice little little features. There's other things, but that's what you have. Filter is, say, you know, filter out the rows that meet this criterion, okay? So here we want storms where wind speed is greater than 50. Boom, it's easy, okay? You can say, I want, you can provide it multiple conditions, like I want wind speed over 50 and that the storm name is one of these 3, okay? So if you just kind of separate these things with commas, it's going to assume that you want this condition applied and this condition applied to filter out the rows. All right, your regular old comparison and logical tests, those are fine, okay? You can create a new column using mutate, all right? So you can say mutate storms, where ratio is equal to pressure divided by wind, okay? And using vectorized operations, it's going to calculate the values, okay? A nice thing about deployer is that you can use the column you just created in the same command. So so for example, right here, it says mutate ratio equals pressure divided by wind, and that creates the ratio. And in the same command, I could say create a new column called inverse, where we do the inverse of ratio. This is normally not possible. Normally you have to create the ratio and create an object with that, and then you can say create an inverse of that thing that I just created and add that. But with mutate, you can, it's smart enough and it will do it in one go, okay? If you're on a kick to create a whole bunch of columns, okay? Mutate must, the result of mutate must have the same number of elements as rows in the table, okay? So if you have 10 rows in your table, then whatever operation this does needs to also produce 10 rows, because you're creating a new column, right? And so every observation needs to have some kind of thing. So so vectorized operations like pressure divided by wind, that makes sense, okay? Functions like sum will not work, because sum will take 10 values and return 1. So sum will not work. But what will work will be things like cumulative sum, okay? Cumulative sum will say, oh, your first number is 1, your cumulative sum is 1. The second number is 2, your cumulative sum is 3. The third number is 3, your cumulative sum is 6, and things like that. And then you will have 10 values being produced, okay? So all of these mutate functions need to produce the same number of values as the number of rows, okay? So things like sum, things like mean, and I don't know, standard deviation, these take a bunch of values and produce 1. Those will not work for mutate, okay? Generally, the vectorized operations where you're going to be doing something, those make sense, okay? But there's other things like figure out the n-tile and stuff like that, okay? These are called window functions, in that you get 6 values in, you get 6 values out. On the other hand, we have summarize, which will take a bunch of values and reduce them down, right? So we can say, I want the median of the amount column, I want the variance of the amount column. This will take 6 values and return 1, okay? And to use summarize, all you have to do is you take, so here's pollution, you call summarize, and summarize is spelled with an S because Hadley Wickham is from New Zealand and they spell it with an S over there, all right? So he's imposing his colonial and whatever, okay. No, we love Hadley for what he's done for R and the R development here, okay? So you can say summarize pollution, and we want to create a new column called mean, and we're going to calculate this by doing mean of the values and amount, okay? And this seems excessive, okay? One thing we can also do is we can pipe things together. So you can see pollution, and this is called the pipe, and you hit Control-Shift-M or Command-Shift-M on your keyboard to do it, okay? So this basically just says take this thing, whatever output is this, and summarize it, okay? And we would get mean 42. So here's, so this is one thing we can do. So you can kind of link these together. You can say pollution, and filter, we want where size equals large, okay? Did I do something wrong? Oh, equals. Gets me too, all right? So we do filter, pollution filter size is equal to large, and it's going to give us just the columns that say large, right? So again, here's pollution. We're going to filter down to size equals large, and what I can do is I can just chain this, okay? And I can just say then summarize it and give me a new column called mean, where it's the mean of amount, all right? And this will give me the mean of these 3 values, okay? And then I can go back and I can do filter size equals small, and this will give me the mean of the small particles, All right, is that okay? Okay, so anyway, summarize, you use the functions that take multiple and shrink them down to 1. Okay, so you're all used to mean, median, summarize. You've got a few other things, first and n, okay, number of values, and these are summary functions. Okay, there's a range, and this allows you to sort things. Okay, so you can say I want it sorted by wind speed. I want them sorted by wind speed descending. Okay, I want to. You can give it multiple things. You can say I want you to sort it by wind speed, and if there's a tie, then break the tie using date. Okay, things like that. So a range just sorts the things. Okay, I guess we talked about the pipe operator. Okay, so these are just saying the same thing can be done this way. Storms, pipe it into filter. Okay, and then again we can chain them. Storms, pipe it into filter, then pipe it into select. Okay, or you can say storms, pipe it into mutate to create a new column called the ratio, and pipe that result into selecting the storm and the ratio. Okay. All right. This is the best part of dplyr, and I've got 7 minutes left. Stay with me. All right. Here we can use a function called group by. Okay, so if we look at pollution, I did 2 operations that seemed very similar, right? I can say pollution filter small and give me the mean, and then I went back and I said filter for large and give me the mean. Okay, one thing I could do instead is I can use the group by operator. Okay, I can say group by.
Change the city back to New York.
Oh, I got to change the city back to New York. Thank you for catching that. Pollution 1,1 needs to go back to New York. Okay. Okay, so I can take pollution, which looks like this, and I can say group by, let's say, the size thing, okay? And then summarize and give me the mean, which is going to be mean of amount, okay? And then it calculates it. It says, oh, okay, I'm going to basically find everyone who has large, and I'll give you the mean of that. And find everyone who has small, and give you the mean of that, okay? Instead of doing size, I can say group by city, okay? And it's going to say, here's the mean of these 2 numbers for Beijing. Here's the mean of these 2 numbers for London. And here's the mean for the 2 numbers in New York. Okay? So what group by does what we call a split, apply, combine. Okay? It takes our data set. It splits them. Here it splits them by city. It applies the functions of finding the mean and the sum and the n. Okay? It applies functions. And then it... Okay, well, and then it combines them. All right, so it's a split, applies functions, and then it combines the table back together, okay? And it does it in one operation, okay? When you just call group by on the table itself, it doesn't look like it does anything. So here's pollution, and here's pollution after I say group by city, okay? It doesn't look like it did anything. This looks exactly the same. But there's this key little piece of information that says there are 3 groups created by city, okay? And that then allows us to do the split, apply, and combine featuring of summarize, okay? So it splits it up, it applies these things, the mean, the sum, and the n, and then it combines them back together. Okay, so this is what we have. Split, apply, combine. And that's featured by group by city, okay? Because otherwise, you'd have to do what I did earlier where I said filter where size equals large and find the mean. And then filter where size equals small and then filter the mean. And then you'd have to do it, and if you had like 10 different categories, this is super annoying, okay? Group by does it in one step, and it will do it for all the categories that appear. You can have if you want to get rid of groups, you can ungroup, do ungroup. Okay, so here's I think, let's see. All right, this is too much. Okay, well, we'll just look at the picture. You can have hierarchical groupings. Okay, so here we've got some I don't know cases of some disease or something, and we have Afghanistan for the year 1999. And for females, there was one case in Afghanistan, 99. Males, there's one case, so on and so forth. What we can do is we can say group by country and year, okay? And this will end up producing 6 groups, okay? Afghanistan 99, Afghanistan 2000, Brazil 99, Brazil 2000, China 99, China 2000, okay? It's going to produce 6 groups, okay? And so when you summarize that, you're going to get 6 rows in the result, okay? However, if you applied summarize one more time, it understands the hierarchy, okay? And it says, well, first we created groups based on country and year, and if we had to further summarize this, there's still groupings by country. And so summarizing this further will reduce it down to 3 rows, Afghanistan, Brazil, and China, because in the group by we said country takes precedence over year, okay? Now if you did it year over country, okay, group by year country, this table would remain the same, but then when you apply the summarize one more time, you would get a row for 99 and a row for 2000, okay? And so group by is very, very powerful, okay? Group by combined with summarize and dplyr, this is probably the most useful thing that has been accomplished for R, okay? There used to be, I mean, there still are functions like lapply, list apply, and they kind of work, and there's sapply for simplified apply, and they kind of work, but a lot of times they break, okay? And but dplyr's group by and summarize features really, I think, do a great job in being able to apply these summary functions for different groups on the data. Okay, we'll end there for now, and we'll see you guys on Friday. We'll talk RVest and all of that.